Okay, good morning to everyone. And that was Rod Stewart, Maggie May. And I just returned a set of homework problems. I'd like to talk about the last one in particular. And that is the problem regarding, did that get sandwiched in with that?
Yes.
Yeah, okay. Thank you. Let me just pass that up. Okay, the problem is this. You have a normal distribution. This is number 46. So if we could, on number 46, take a look at that one. And you are told in the first part that x is normally distributed. And what are your numbers there? For
Mu is 537.
537?
Yes.
And standard deviation?
116.
116. And I believe in this case you want to know the probability that x is greater than, and what's the number?
750.
750? Now you could technically say greater than or equal, or just greater than. But the first thing that I would expect you to do here is to sketch yourself a bell-shaped curve and indicate where its center is. So the center is at 537. And to get an approximate area related to 750. Well, if I add 2 standard deviations, that'd be 232. So that would put me up at 769. So I'm just a little to the left of 2 standard deviations. This is 1 standard deviation where the curvature changes. And then we have equivalent distance out here. So somewhere about in here is your value is 750. That's the first thing I would expect to see in this solution. Draw the curve and relate to it the area associated with the problem. And it's a probability statement that you're trying to do. Now the next step is to have a formula for the substitution for z. So you're going to have z equals x minus mu. It's going to be over sigma. And I simply substitute. So I have 750 minus 537, and that's over 116. And I believe that gave you a 1.84, is that correct? 83, depending. I saw different answers at 183, 184. I think I found 184 more often on papers than I did 183. So somewhere in that region. I'd need to be a little more precise there, carrying it out. But what are you going to then write? You're going to write that this is equal, that is, I can come down here and say what I'm after. And you can have equality or not, because there's no area at the equal sign. And I'm arguing that that is equal now to the probability that z is greater than or equal to 1.84. Now the thing you have to be careful about is that your table gives you the area to the left, not to the right. So I would prefer, in terms of the table, to just rewrite this so I can look up the value directly and not have to depend on any symmetry arguments. So when I look this value up in the table, I subtract it from the 1 to get the answer I need. So if you look up 1.84 in your table, you're going to get a value that's 0.9. And my guess is it's going to be 0.98 something. What is the number at 184? You'll be page 685. On 685, what do you get when z is equal to 1.84? 1.84. Erlinda?
0.9671.
9671. That is then subtracted from the 1 and gives you a 0.0229. 0329, I'm sorry. Roughly 3%. That's what I need to see in documentation. The curve, the formula, and the associated probability statements. Now, we talked about this before. This is part A. Part B, I believe you get a 2.26 for your Z. Is that correct? And then your area is much less, but it's not so much the difference between these two parts that I'm interested in. It is the documentation you provide, because if I ask a question like this in the test, this is what I expect to see for full credit. Is there any question? Whenever you use table A, or you write Z, I want to see a curve. I also want to see the formula for Z, and then I want an appropriate statement with probabilities. Now, the place where some of you messed up, you tried to tell me that this right here was equal to 0.9671. Again, you're telling me the probability to the right of 1.84 is equal to something around 97%. But if you look at your diagram, clearly it has to be smaller than that. You must be more critical of what you are writing. The area to the right of 1.84 cannot be even 50%, let alone 97%. So watch your statements. I have a lot of addendums to your work as you wrote out the statement. And if you omitted certain parts, then I took off credit. Now, overall, the scores were much better here. I had a lot of 9s, 8s, 7s. But on a test, this would cost you 2 or 3 points on a problem for simply not documenting it so that it makes sense. You're in danger of saying things like 2 equals 3. And that's in essence what happens here. When you say this is equal to 0.967, you're saying something like 2 is equal to 3. It simply does not work. And what you write, if it's inconsistent with what is supposed to be there, I think it potentially causes confusion in your head as you try to do it. So that was probably the most concern I had. Number 10, I tried to go through your work and, again, annotate it in such a way that the statements you were making are valid with probabilities. And I had asked you to do these problems in the spirit of what I've been doing on the board, showing documentation. Any questions? Okay.
Actually, so
Okay, Sean?
go to, so we have the P% probability of Z being greater or equal to 1.84. Then the next time we switch the greater than or equal to sign to be less than?
Because when you look at the table, it is the area to the left that is the 0.96. This has to be consistent with the value you're getting. Now, what was the alternative that you had if you didn't want to play the subtraction game? And I didn't see this done on a single paper.
Symmetry.
The symmetry, and I could have said that this is the same as the probability that Z is less than or equal to a negative 184 and been there one step. So I could have said this. And if you'll look up negative 184, you should find that this probability I have right, okay, you switched on me, that this is exactly what we're getting down here. Is that correct? If you look at your 684 now, on 684, you could find that directly, but your diagram has to be consistent with your notation. And that's the finesse I'm not seeing right now. Again, 684, look up a negative 1.84. Do you see the 0.0329? Now, we may be off in one digit, but that would be about as bad as it's going to be. Any question there? Okay. And I thought it was important to bring this up just from the standpoint that we have an exam coming up and that you need to be a little more careful in how you write out your solutions. Are there questions about the lab? Yesterday we talked about the box plot lab. Did any of you manage to get out to Sierra Hall 221? Did Clorinda give you the shortcut?
I don't know.
Okay. She'll give you a shortcut for finding suspicious points, so you don't have to click on each of those little squares. It's worth going out there just to find out how to do that. Any questions, though, about the box plot lab? Now, in the part where I ask you to calculate the fences, I want the formula each time you use it, the substitution and your answer for the 4 fences for LEF and for the 4 fences for LEM. Those are given as formulas on 5-4 of the lab manual. Now, you are not obligated to use Roman numerals for Q1 and Q3. You can just use good old Hindu Arabic at 1 and a 3, but you do have to give me the IQR and the substitutions. If there are no questions on that, how are we doing with what we did yesterday, where we calculated little r squared? If I ask you short answer type questions, the following. What do we call r squared and what does it represent? Run that through your head for a moment as a kind of mental answer without writing it in paper. Just what would you have in your head? Again, if I ask you, what does r squared equal and what does it represent? I'm just giving you a chance to think about that for a moment. Okay, what kind of answers do we have that are floating in your head? R squared. What do we call it? We had a name for it yesterday. The name I was hoping you'd remember, coefficient of determination. What did it represent? That's more important than what we called it. What did it represent? Percent of the variability of y. Okay, explained by the linear model. You're reading well. Okay, so you wrote down what we had on the board. It is the percent of the variability of y explained by the linear model. What value of r squared, or r, you could do it either way, would be considered a good value, a strong value, and why?
0.8, negative 0.8, it's like negative 1. Really anything over 50%.
Okay, r squared, anything over 50%, because 0.7 squared is 0.49. So as a tenth, anything between 0.8 and 1, between negative 0.8 and negative 1 would be considered a strong relationship, meaning most of the points are close to the line. How do you calculate r squared? What's the formula? Okay, what I heard was SSR over TSS, but it was verbalized sums of squares regression over total sums of squares. So it's SSR over TSS. And remember that TSS can be broken down into what? 2 parts. You have good notes. SSR plus SSE. Got it? So we've done 2 things. We've done a scatter plot. We have generated out of that scatter plot a line. We have created a line. Now, it's a line that we believed was the best we could do to get points on the line or close to the line. Then I ask you to get the equation of the line you drew. Then we found the equation for that line on the calculator to compare to see how good we did. And then yesterday we looked at what r squared means to address the issue of the relationship between the 2 variables. Now, there are a couple of nice diagrams in your book that I think are beneficial to you to get a handle on what r looks like, or what I should say the scatter plot looks like, for values of r that are close to 0 and close to 1. Let me go to page 102. So if I go to page 102, and again, these are scatter plots, and as I look at this first one, this is r equals 0, and you might think of this being something like tossing a handful of pebbles into a pond. and you just see a kind of concentric circle ripple going out. There's a little bit of a linearity that I see there from the standpoint that right up here, this top part gives me a sense of something about like this. If I take, sorry, I bumped the camera there, but if I take this point off up here, maybe these 2 points, now it's starting to look like what? More of a circular pattern. Now that's r equals 0. Now 0.5 is right below it. Okay, there's 0.5. And you can start seeing a linear trend, right? I think you'd be hard-pressed trying to fit a line to that to where you could argue that you have the line of best fit, meaning points as close to it as possible. So we come off there for a moment. I'm going to bring the camera down to the next extreme. And this is where life starts getting pretty good. But remember, we're only explaining 80% roughly of the variability. This is at 0.9. And I think you could draw a line there pretty well. Now when you get anything above 0.9, and this is at 0.99, and notice this is a negative value, and notice the negative slope, but that would be an easy one to draw the line on. Agreed? Okay. On the test, I'm telling you right now what I'm going to ask you to do relative to what we've done the last 2 days and what we're going to do today. I am going to ask you to do a scatter plot. I am going to ask you to draw the line just like we did on Monday. And I'm going to ask you to get the equation of your line. That's a 10-point problem. That's an algebra problem more than it is a stat problem. And like we did yesterday, I will give you a set of ordered pairs. Maybe 6 values like we did yesterday. And I may give you, most likely will give you, y hat. Then I will expect you to go ahead and get the residuals, that's y minus y hat for each pair, square those residuals, and by using SSE and calculating TSS, be able to get little r squared by taking SSR over TSS. That'll be 10 points. 2-letter grades in the last 2 days. How do you find TSS? What was our shortcut? Look at your notes. Shortcut for TSS, total sums of squares. Do you find it in your notes? It's SSR plus SSE, but how do you find TSS? Because you're hunting for SSR. You won't know SSR typically.
The summation of y minus y hat squared over n minus 1.
That's SSR. I think if you said y hat minus y bar squared?
No, y minus y hat squared.
No, if it's y minus y hat, quantity squared, that's SSE. I want TSS.
Right? Equals
Say it again, Ashley.
y minus y bar.
Okay, the summation of the y minus y bar quantity squared.
And then you have equals n minus 2 s. Right, right. N
Close. N minus 1.
Sorry, and then s.
Okay, that is correct. So TSS, let me write that on the board. The total sums of squares is this summation. And what you're supposed to recognize is that the quantity I have on the right side is the numerator of the variance of y. That is, if I ask you for the variance of y, we oftentimes do not include the subscript. You would just write the summation of y minus y bar squared, and you'd have it over n minus 1. So if you are trying to remember how to get TSS, and you know how to get s squared sub y, you cross multiply. So this is the n minus 1, times the variance of y gives you the summation we want. So if you have the data in your calculator, all you have to do is hit the SY key and square it. And multiply by n minus 1 and you have it. Now if I don't expect you to put the data in your calculator and I give you a table with the y hats, then all I have to do is give you this and you should know what to do with it. If I give you S of y, I've given you the standard deviation of the y's. What must you do first? Square it, then multiply by n minus 1 to get the TSS. You're getting your SSE from where? Where does that come from?
The summation of y minus y hat squared.
Okay, the summation of the quantity y minus y hat squared. That's what we got from our table. We had a column for y, a column for y hat, then we subtracted to get the column of e, then we squared the e's and added those up, and that was SSE. Now the SSR, technically you could get if you wanted to put the time into it without using the formula we talked about yesterday, in which I have TSS is equal to SSR plus SSE. So the idea was if I can find two of those, I can go ahead and subtract to get the third using basic algebra. But I could have simply done this because I had the y hats. I could have taken y hat minus y bar and taken the summation of the squares of those directly. That would be an option. Just as a question, what was the summation of E? From yesterday, when we added our errors. It's one of the conditions about those errors. Okay, Daniel says 0. Yes. The summation of the E's is 0. Now, from a practical point of view, if you're doing the calculations, you're going to what? Get something close to 0. We lucked out and actually got 0. Now, each of these E's is called a residual. And so, if we look at the residuals, this gives us something about the properties of the residual. The average of the residuals will be 0. E bar is the summation of the E's over N. But the summation of the E's is 0, so we are going to have an average residual of 0. That's one of our properties about residuals. Now there's another property about residuals that we have to inspect, and we get that from the residual plot. We need to do that now. A residual plot. What I need to have on the x-axis, your birth rates. The vertical axis, the values of E that we had from yesterday. So, piece of paper, straight edge, draw me a coordinate system. Horizontal axis, birth rate. Vertical axis, E. Okay? Now, the data set, as I come back to center, we had yesterday, and I'll put that under the document cam, get this out of the way. Try to get that in a little better focus. Okay, here were some of our Y's, Y hats, and E's, correct? So those are values that we should have written down. I say we in a kind of, and I'm still going to be over here, but no, I maybe go over here. These are the values I hope you and I both have on paper. How's that for a different way of saying it? And I am bound and determined not to have this thing look skewed because of the way I'm drawing it, even though the camera may give that impression. So I'm going to draw a horizontal line. Okay. Not too bad. And I'm going to have a vertical line. And I've indicated this is the value of E. And here are going to be my birth rates. So that'll be my horizontal. And my birth rates went from what? A value around 10 to 20, is that correct? Somewhere in there? Am we in agreement there? So let me do something like this. Let's call this 5, 10, 15, 20. So I have 5, 10, 15, and 20. So that's what I'm going to have there. Let's go back to the document cam for just a moment, Jennifer. The values, I think the largest one was that negative 685 in absolute value. That was my largest residual in absolute value. Is that correct? So the vertical scale, I'd like maybe to go up to around 7 or 8. So let's do 2, 4, 6, 8. Down here, 2, 4, 6, 8. So this is a positive 2, positive 4, positive 6, positive 8, negative 2, negative 4, negative 6, negative 8. So I'm going to have to do some rounding in order to plot these points. And remember, the point I'm plotting is XE. So I'm looking at the plot of X comma E. That's my plot. And we're going to refer to that as a residual plot. So let's go back to the first. I have a residual of negative 1. What I can't read on the screen, unfortunately, is my X value. So what was the X for that first ordered pair? Somebody share that with me, please. 17, roughly. Agreed? So 17.5's there, where I have that little hash mark. So 1703, just going to be a little bit to the left of that midpoint, and I'm supposed to go down to about negative 1. So I believe my point is about there. Otherwise, this is between 15 and 20. There's 17.5, so maybe a little bit to the left of center, and it's down negative 1. My next point, as we go back to the document cam. Now I have a negative 1.5. What is my X for the second ordered pair? 10.71. So that's at about 11, pretty close to right in here. And back to the document cam temporarily. That was reset at negative 1.5. So this looks to be about negative 1, negative 1.5, about somewhere in there. And I'm not doing the neatest job. This might be up a little bit higher at about there, so that the scale is reasonable. So negative 1, negative 1.5. So I have two residual points below the x-axis. Let's go back to the document cam. The next one is at plus 1. What is the x for that value? 787. There's 7.5, so about right in here is the other one. Now notice, these are sort of balanced. This is supposed to be at 1, and that was supposed to be at negative 1. So I'll make them big enough that they're sloppy enough that it's somewhere in that region. But I have them on both sides, correct? 3 points so far. Any question with what I've done at this time? Let's go one more. Back to the document cam. I think we're at point 4 now, and that is at 4.7. What is my x value on that one? What is it? 21? 21 right about in here. And we're going all the way up to, what was it? Document cam? 4.7. So there is 5 coming across there. So just a little bit below, I have a point something like that. Okay? Much larger residual, correct? Next one. What do we have as we come back? We're at a negative 6, nearly a negative 7. And that was what x? 22 roughly. So as I get up here to about 22, I'm all the way down to around negative 7. So it looks like a point about here. Now those two residuals are rather large, correct? They're on the right side. Okay, let's go for the next I can't read. I have 2, 4, 5. Let me bring that down so everybody can see it. Maybe I can get a little better positioning on that. Okay, it's a 361 is what I'm reading there. And that's at 21 also, correct? Roughly 20.92 does at 22. So we're roughly at 21, and I'm at 361. So 361 at 21. 21's about in here. And 361 is going to be something like this. Now, the large residuals are for the large values of x. Agreed? Small values of x have small residuals. And so as I look at this, I would be inclined to observe that as I go from the left to the right, things fan out, correct? The residuals are larger for the larger values of x. So this tells me that for large values of x, I make bigger errors in my predictions. So again, less accuracy for large values of x when I try to predict y. For small values of x, I do a pretty good job, it seems. Now, we saw that yesterday as we looked at, what country was it? We estimated something like 68 that you were going to live to as a woman, and you died at 32. Swaziland? Okay, so we looked at Swaziland. Now, that was a very large X. We said that we predicted something close to the 60-70 range, and the residual was like 30-some years, which is saying that for large X, we're going to have very bad estimates. Now, what was the downside of estimating using this model? Why did we argue that we shouldn't have been doing it? I gave you a rule of thumb that you could follow. What was that rule of thumb? Something to do with the 20% rule.
You were supposed to go 2% over, only 2 years over 20%.
Of what? What? Not the standard deviation. We talked about the range of the x values you had. The x values went from what? Roughly 10 to roughly 20. Now, it dropped down to 7 something. If we go back and look at our data, I still can't see that first one. But we see a 787 for the third one. So we're down around 8 up to about 22. Range of about 14. Take 20% of that range. 20%. 20% of 14? 2.8? Roughly 3? So that says I could add 3 to my 22, get up to 25 and feel good about it. Or I could go down maybe to 4 and make a good estimate. But what was the birth rate for Swaziland? Birth rate for Swaziland? Was it only 26? It seems small to me. Will you check your database? It seems to me that that is a little bit small, but I may be in error there. Is it 26 for Swaziland? Okay. 26 what? My error. I just didn't remember that. 0.6? And the actual life expectancy female was what? 32.3. When we put this into our equation, and our equation was y hat equals negative about 0.89x, I believe, plus 92. How far off am I in that? The equation that we generated. Refer to your notes. This is not the one we estimated, but the actual equation of least squares.
Negative 91.57.
This was 91.57? Okay, and what about my slope?
Yeah.
I'm okay there? That was our equation. And by the way, I said just now, line of least squares. So just a quick question relative to that. What do least squares represent again? What does S, or least squares, represent? Okay.
The line that's closest to all your data points.
Well, that's the line we draw, but the least squares refers to SSE. So it is the line we draw, but we are minimizing the sums of those squares of errors. So when we say least squares, we say we have a minimum of this. Any other line we would draw would have a larger sum of squared residuals. Now, how much did we exceed? We went to 26. We're past the 20% rule. Okay? Should we have much faith in our estimate? Well, if I put 26 into here, and the whole idea, and again, just to remind you, that when we placed this 26.6 into the calculator and then hit the gold key and hit the Y primed, we were asking it to do this calculation. And when we did that, my recollection is we were in the 60s. And what did we get from your notes? 68.01. So we were predicting 68 years. Reality is you have a life expectancy of 32 years. We're off by a bunch. Not a very quantitative statement, but I think it's very clear that we have done a very poor job in our estimate. Now, more to the point, what should this residual plot look like? And the answer to that, a random distribution of points on both sides with no pattern. So if you see a pattern, like I have there, we worry about accuracy, but you sometimes see a curved pattern, like a parabola. Now all that's telling you is that your original scatter plot did not support a linear model. Residual plots are something that you should look at. What I've just illustrated here is worth about 5 points in the test. I will expect you to be able to do a residual plot and discuss it. Okay? So I'm trying to be extremely informative about what you have to do on these two chapters. I gave you a handout. Have formulas on it, right? Okay, so we need to see how we would generate these values of R, A and B, using those formulas. So the first thing to observe from yesterday, I said something about this. What was my comment about X bar, Y bar? Very good. Nick remembered. Without having to refer to notes, I am impressed. No notes. X bar, Y bar on the line. Can I use that to my advantage? That's rhetorical. The answer to that question would be yes, I can. Because I could say this then. If I use the notation from your algebra class. Now remember, we had two notations you had to be careful of. This is the notation from your algebra class. And if you look at it from the notation of the typical stat text, okay, it gets a little bit confusing because the B now is your slope rather than your intercept. But if I knew the slope, I could find the intercept very easily, correct? If I knew the slope, I could just say then A is equal to Y bar minus BX bar. And I believe that's one of the equations on the page, is it not? Do we concur? Should be one of those equations. I think in this form. Maybe B sub 0 is equal to Y bar minus B sub 1 X bar. because I mentioned to you multivariate, we talk about b sub 0 and b sub 1 rather than the a and the b. The equation for r, not so nice. Okay? It is a mess. Okay? Now in the denominator, double not nice. Okay, at this point with camera 1, Jennifer, could you go right below the clock where it says s squared sub y equals the summation of the y minus y bar quantity squared over n minus 1? Can you go there, please? That's what I want. What do you call that formula for s squared? Now, again, we could get s by taking the square root of both sides. We had a name for this formula. We called it, in contrast to a computational form, a also starts with the letter C. How about conceptual? This is the conceptual form. Otherwise, what does variance mean? It's just the difference between the middle of the distribution and where each point is. So the further the points are from the middle, the greater the spread, the greater the variability, hence the greater the variance. Now, I traded that in, and I don't know. Yes, we're just going to take camera 1 and slide over here a little bit. The more appropriate phrase is pan, but slide I like. What was the computational form for S? I'll help you. It has S on this side, and it has a square root. Okay, I've given that as much help as I'm going to give you.
Summation of x squared
Okay, good. Sean's got it going.
minus the summation of x quantity squared.
Okay, good. For the numerator, nail it now. You've got one more line to go.
N minus 1 times n.
We usually say n times n minus 1, but you just won the trip to Ripon. Okay. Can't afford Hawaii, but we can manage Ripon and a coffee stop in the way. That's the computational, right? Now, back to the sideboard. Look at your denominator of R. I haven't seen that page in a couple of days, so I'm going to just ask, what do you see in these radicals? Does it look familiar? What are you in essence seeing when you look at the radical in each of these two radicals? It's like seeing the standard deviation of x and the standard deviation of y, correct? Except you aren't seeing the n minus 1 on the bottom. Fair enough? Okay, so you're going to write n summation of x squared minus summation of x quantity squared, and n the summation of y squared minus the summation of y quantity squared. Agreed? Now, the numerator is something like what we call covariance. Okay, now, with this in mind, it's sort of taking the difference between x and x bar and y bar. So in reality, if you looked at it for a moment, we talk about what's called covariance, COV. It would be to take the summation of x minus x bar times y minus y bar, so you aren't squaring either the x minus x bar or the y minus y bar. You're taking that product. Right? Now, the conceptual is this for covariance. The computational form is to do this. In the summation of x, y, minus the summation of x times the summation of y. Have I got the formula written now? You got the page. You're looking at it. Does it work? Okay. Now, in a sense, if you think of what I have up here, now I'm, for the moment, negating the n minus 1 times the n and all that's going on there. But we said this is like sigma x and sigma y? Yes. So I could put this over this, and this over this, but that's an error because it's not sigma at that point. I'm actually dealing with s, not sigma. My error. Okay? No, I didn't. That was just very careless on my part. Thank you, Ashley. Thank you. I would have catched that. Right now, I can't even see the y because of the glare on the screen I'm looking at on the monitor. But you are right, because what I'm going to ask you to see next would not make sense otherwise. Do you recognize this? No? Yes? No? We have said that z is equal to x minus mu over sigma if we know mu and sigma. But if we don't, and we have x bar and s, then we say simply that z is equal to x minus x bar over s. So that would be a z sub x, and this is a what? Z sub y. So I could rewrite this as the summation of zx, zy. And as I say, I just have a minor problem. I haven't dealt with the ends very well. And we had the square root of m times m minus 1 in both of those. And the point being, when you get everything's done and said, we could just argue we'll put this over m minus 1. Okay. Leave that there. Now I've got to find what I'm after. I'm going to do a couple things in your text. I'd like you to turn to page 120. And here's the formula that we wrote on the board just a moment ago. This is page 120. And I have A equals y bar minus B x bar. That's exactly what I have on the sideboard. Okay? So that's your documentation there. Then going back to chapter 4, page 100. This is the formula your text uses for R. What I have on the board, it's just I rewrote x minus x bar over s sub x as zx, y minus y bar over sy as zy. So I have the summation of the zx zy over m minus 1. Okay? Back to the sideboard. So this is a way of getting R. I have more space on the right than I do at the left, so I put it there. Bring that in a little bit tighter if you could, please, Jennifer. Now, that formula is easy to remember. Zx, zy over m minus 1. You take the summations. Now, what do you have to do to play this game? You need a column for y minus y bar over sx. And you do that also for the y, because I have to get both these z's and then take their product and add them all up. Conceptually, it's great. Computationally, no. So let's slide. Your calculator gives you keys for the summation of xy, the summation of x, the summation of y, the summation of the x squareds, the summation of the y squareds. Do you still have your data in the calculator? Some of you do. For those of you who do, let's provide the substitution now. By the way, this is now worth 5 more points on your test. Okay, so just trying to keep track of what you're getting. You have your calculator. We know n is 6. That's the number of ordered pairs, correct? Okay, so I've got a 6. Now, do you see the summation of xy as a key? What key do you see the summation of xy on? The 1 key? Superscript for the 1 key. So if you hit RCL, the 1 key, you should be able to give me the summation of the xy. Okay, Nick, give it to me, please.
7,497.20.
I'll be, for the sake of sanity, go to hundreds. Where do we find the summation of x? What key? The decimal key? What do we have for the summation of x? Recall decimal. 99.6? Okay. What do you use for the summation of y? The 2 key? Recall 2. What do we have? 461.18. Thank you. Okay, numerator's done. And by the way, I don't expect you to grind this out. We're just showing the substitution. Remember what I ask for documentation. Formula, substitution, and answer. Now we can hit a recall R and get the value. I just need the substitutions. So down here, I know I'm going to have a 6. I'm going to have some value here. Where do I get the summation of the x squareds? And I don't know if I have that large enough for the parentheses, so let me get rid of that for a moment. What key? Just look at your keyboard and look for a summation of x squared. The plus or minus key? What do we have? 1832. Any decimal? So 17. I'll just round off to the hundreds. Then minus. Now I already have the summation of x, right? So that's just going to be a 99.6 squared. I don't know if I planned well enough or not. I'm starting to look like I'm running out of room here. 6 times the summation of the y squareds. Where are you picking up the y squareds? What key? You just have to look at the keyboard, and it's there. So 3, recall 3. What do we have? 35,674.74. Then, I already have the summation of y, so I'll put in here 461.18 and square it. That's it. Now, what's the value? Where are you going to find that?
Recall R.
Okay. Either a gold R or a recall I. What color is R in? Green? Okay, recall it. What key? What is it? Okay, recall divide. What do we get? Remember we said yesterday it rounded off to negative 0.79? You're done. Okay, we need to do one more thing because we still need to finish out our value for A. So, sliding over, here's our formula. I probably should have put this in a box. I didn't, but that's okay. A. Now, where are you going to get y bar? What key? 7. What does it say? Seven, 6.83? 866. 87? 86. Okay. Minus, now do I know the slope? No. I'm in trouble. But I know x bar, so I need to put something in here. Now, we happen to know it's negative 0.89, but I've got to establish that. What's x bar? I did realize I have something yet to do. X bar. What's my number? 16.6. Okay, now the question, how am I going to get B? Well, if you've got R, B's pretty darn easy. So let's slide back. What of R is in B? That's stated badly. Look at your formula on the sheet I gave you for B. Does it look a little bit like R? What's the same and what's different for B? There we go. The numerator's the same. And the denominators, throw out this part and throw out the radical here, and you got it. So B is going to, okay, let me do it over here. B is, and I do the same substitution, summation of x, y minus the summation of x times the summation of y. And then in the denominator I have in the summation of x squared minus the summation of x quantity squared. And I just substitute and I've got it. Right? I expect you to be able to put all those formulas down on the test, substitute and get the answers for about 5 points to 10 points. Okay, in 3 days I've given you 30 points of content. Know how to do it. I'm out of time. We've been listening to Rod Stewart.